Hello, good day to all. So today we are going to discuss about the topic factor analysis. Now before moving on to what is factor analysis, let us see some basic terminologies that we are going to use uh, always while we are carrying out the lecture. So basically, the first terminology that we are going to interchangeably use is the term variable. Variable is something that which is varying, or in a simpler term, it is a item that we are going to measure during your analysis. So item or questions is again a set of variables which are used to measure the particular aspect or particular concept, right? And another terminology that we usually use is factors. So factor is a set of observed variables that have similar response pattern, right? So say you have selected a set of variables like age, gender, then sex, salary, like that, and you term or you name all these variables into a single factor known as socio-economic profile. So that is a factor, right? But it will have a similar kind of response pattern. That is called a factor. Now, we will start to discuss about the factor analysis using a simple example. Say you are going to visit a store, okay, and you wanted to find out how is this service quality of that particular store. So there are certain items or certain things that you wanted to measure which can or cannot be related to service quality. So what you basically do is you go through all the literature related to service quality, and then you have prepared a set of variables that you feel that it is related to service quality. So for example, the salesperson listens to me, the salesperson has an international expertise, salesperson demonstrate added value when you are selling the product, you have a balanced service cost, the salesperson transfer the knowledge very efficiently, treated as an important client, accurate services, delivered on time, understand the business. So these are some of the things that you feel that which will define the service quality. So why do we use factor analysis? We use factor analysis in order to reduce the dimensions of this particular service quality, because here if you are trying to interpret the service quality using these many variables, it is going to be very tedious task, right? So instead what we do is we reduce these dimensions into smaller factors which can be explained better in a better way. Say, check this out. Here, you can combine variables like listens, treated as an important client, accurate services, delivered on time into one single factor known as the quality of service. Right? Similarly, you can combine demonstrated added value, balanced service cost, transfer the knowledge, etc. into a single factor called as value for money. Factor is also a variable. It is just that we are terming it as a factor so that we can identify it, right? So this is factor analysis helps you in reducing the number of dimensions into small manageable factors which can be used for interpreting your result. So one thing we have to keep in mind that during your factor analysis you are considering all the variables that you have and there is no dependent variable here, because you are considering all the variables as a single set and then you are doing the factor analysis. So factor analysis is general term denoting a class of procedures primarily used for data reduction and summarization. So factor analysis is an interdependent technique in that an entire set of interdependent relationships is examined without making the distinction between dependent and independent variables. So in factor analysis, there is no independent variable or dependent variable. It's just a technique used to reduce the number of items or number of dimensions into manageable chunks, right? So it is easier for us to explain or interpret the data. So basically factor analysis is used in following circumstances. One is to identify underlying dimensions or factors that explain the correlation among a set of variables. So the basic analysis that we do here is the correlation, which we are going to see in the later part of the lecture. Second use is to identify a smaller set of salient variables from a larger set for use in a subsequent multivariate analysis. So this, when you reduce the dimension into manageable factors, it is easier for you to conduct further multivariate analysis. So for that purpose, you use factor analysis. Now, what is this factor analysis model? So say you have selected around 20 to 30 variables which you feel that, okay, that will describe about the particular concept, right? And after doing the factor analysis, you feel that again you have 4 or 5 factors which best describe the number of dimensions that you have selected. Sometimes it may so happen that you can say that, okay, the factor 1 explains better because it has, say, 50 or 60% variance, right? Second factor less explains. Like that we can assign scores to those factors after doing the factor analysis, right? Now, factor analysis can be classified into 2 types, that is exploratory and confirmatory. In many of the research studies, we do exploratory factor analysis when you don't know about that particular variable, right? You are not sure about the structure of your data, or how many dimensions you have, or how many set of variables you may receive after conducting the factor analysis. So in such situation, you use a exploratory factor analysis just to explore the dimensions you have selected. For that, you do a exploratory factor analysis. Second type of factor analysis is confirmatory factor analysis, wherein you're confirming that, okay, the data set or the set of questions or the set of dimensions that you have selected has, say, 4 factors. For example, in the service quality example, we have selected around 10 to 15 variables, and once after doing the factor analysis, you have got around 4 factors. So this may be available previously, right? So here your intent is to find out that it is correct. So for that, you use a confirmatory factor analysis. Now, once you do factor analysis, you get a set of statistics. We'll see what these statistics stands for. The first one is Bartlett's test of sphericity. Bartlett's test of sphericity is a test statistics which is used to examine the hypothesis that the variables are uncorrelated in the population, right? So in as I told you earlier, in factor analysis, you are selecting all the variables together, right? So you wanted to ensure that these 20 variables that you have selected from the literature are totally uncorrelated. So this statistics will help you to say that, okay, all the 20 variables that you have selected are totally uncorrelated, right? Then you get a correlation matrix. So from the Bartlett's test of sphericity, you can say that whether the variables that you have selected are correlated or uncorrelated, and you also get a proper correlation matrix. From there, you try to find out how much correlation is there between the variables. Then another statistics that we get is communality. Communality is the amount of variance the variables share with all the other variables being considered. Right? This is also proportion of variance explained by the common factors. So communality is nothing but the amount of variance which you can observe in the data set. Right? Another statistics is called eigenvalue. The eigenvalue represents the total variance explained by each factor. And many a times we use eigenvalues to determine how many factors you need to select. Say, as I told earlier, you have a set of 20 variables, and from there you have reduced those into say 5 or 6 factors. And how do you select these 5 or 6 factors? You are selecting using the eigenvalue. So thumb rule says that if the eigenvalue is above 1, you can select it as factors. Right? So if there is any value below 1, you don't select it. If it is above 1, you can select those factors and you can then name those factors. We'll see that in the later part of the lecture. Another set of statistics that you will get is factor loadings. Factor loadings are simple correlation between the variables and the factors. Right? How much correlation is there between the factor and the variable, that you can observe using the factor loadings. Another important statistics is the factor loading plot. A factor loading plot is a plot of original variables using the factor loading as coordinates. Factor matrix is another statistic that you will receive when you conduct a factor analysis. A factor matrix contains the factor loadings of all the variables on all the factors extracted. Right? Now, next one is the factor scores. Factor scores are composite scores estimated for each respondent on derived factors. Then there is another statistics also known as Kaiser-Meyer-Ulkin KMO, measure of sampling adequacy. Right? So this is an index used to examine the appropriateness of factor analysis. So say you are getting high values between 0.5 to 1, which indicates that factor analysis is appropriate. Values below 5 imply that factor analysis may not be appropriate in that particular research problem. So using KMO, you can say that factor analysis can be done to that particular data set. Right? Then another set of statistics that you will receive is the percentage of variance. The percentage of total variance attributed to each other can be observed in percentage of variance. Then there is something called as residuals. These residuals are the difference between the observed correlation as given in the input correlation matrix and the reproduced correlation as an estimated from the factor matrix. So the residuals will give you information regarding the difference between the original correlation matrix and the factor matrix. So it is a difference between the input correlation matrix as well as the factor matrix. Another set of plot or statistics that you will receive in factor analysis is called as a scree plot. A scree plot is a plot of eigenvalue against the number of factors in order of extraction. So if you observe the scree plot, you can decide on the number of factors you have to choose. Right? So what is the thumb rule? Thumb rule says that if the value is above 1, then you can select that particular factor. So how do you conduct factor analysis? We can do it in a step-by-step manner. The first thing that you have to do is formulate the problem. Now, how do you formulate the problem? First, you have to find out the underlying objective for doing that particular factor analysis. The variables to be included in the factor analysis should be specified based on past research theory and judgment of the researcher. It is important that variables be appropriately measured on an interval or ratio scale. Right? So ordinal and nominal data cannot be included for the data analysis or factor analysis. Right? An appropriate sample size should be used as a rough guideline. There should be at least 4 or 5 times as many observations as there are variables. Say if you have 20 items or 20 questions or 20 variables in your data set, then your sample size should be 20 into 5, that is 100. So minimum 100 data observations should be there if you want to conduct a factor analysis. Right? So how do you select these variables? It is using the past research or the judgment of your researcher, or based on any kind of theory, you select those variables that you need to consider. So after conducting the factor analysis, you can say that sometimes it may so happen that out of 20 variables, only 10 will be related to that particular analysis, or say that particular concept. So other 10 you need to discard. So you will get a proper proper set of variables after conducting the factor analysis. So, next is construct the correlation matrix. So the analytical process is based on matrix of correlations between the variables. So when you construct the correlation matrix, the first thing that you will do is test the Bartlett's test of sphericity, which can be used to test the null hypothesis that the variables are uncorrelated in the population. If you have a very highly correlated result, that means that there is something wrong with the analysis. You cannot conduct that factor analysis there in that particular data set. That is the overall interpretation from Bartlett's test of sphericity. Another useful statistics is the Kaiser-Meyer-Ulkin KMO test of sampling adequacy. So KMO test will tell you about the appropriateness of using factor analysis in that particular research problem, right? Then there are around 6 methods of conducting factor analysis. The first one is the principal component analysis. So in the next step, what you do is you select which method of factor analysis are you going to follow. So in SPSS, you can just select that particular checkbox, that which kind of factor analysis you are going to follow. So first one is the principal component analysis. Here the total variance in the data is considered. The diagonal of the correlation matrix consists of unities, and full variance is brought into the factor matrix. Principal component analysis is recommended when the primary concern is to determine the minimum number of factors that will account for maximum variance in the data for use in subsequent multivariate analysis. The factors are called as principal components in principal component analysis. Right? So here you check the total variance using the correlation matrix in principal component analysis, and you use this particular type of analysis when you wanted to find out the minimum number of factors that will explain about the maximum variance in the data, and this can be used for further multivariate analysis. In such situation, you go for a principal component analysis. The second type of factor analysis is called as common factor analysis. The factors are estimated based only on the common variance. Communalities are inserted in the diagonal of correlation matrix, that is it will be 1. This method is appropriate when the primary concern is to identify the underlying dimensions and common variance of interest. This method is also known as principal access factor. Now, next type of factor is a priori determination. Sometimes because of prior knowledge, the researcher knows how many factors are to be expected, and thus can be thus you can specify the number of factors to be extracted beforehand. Right? Say you must have done that particular research earlier, and you know, okay, for that set of 20 variables, you may get around 4 or 5 factors. Then you can actually use a priori determination method, wherein you can actually specify the number of factors. So in the SPSS console, you just give the number of factor as 5 or 4 according to the problem, right? Then they will say that, okay, there are 5 or 4 factors in the data set. Another type of factor analysis is determination based on eigenvalues. This is the most commonly used technique. That is, you find out the factors using the eigenvalue. In this approach, only factors with eigenvalue greater than 1 are retained. An eigenvalue represents the amount of variance associated with the factor. Hence, only factors with a variance greater than 1 are included. Factors with variance greater than less than 1 are now better than single variables, since due to the standardization, each variable has a variance of 1. If the number of variables is less than 20, this approach will result in a conservative number of factors. So, if you have a data set with less than 20 variables, sometimes it may so happen that when you do eigenvalue based factor analysis, you will just get 1 or 2 variables. That can happen, right? So in eigenvalue based factor analysis, what you do is you select only those variables which has the variability of 1, right? And in some cases, in some very rare cases, you also select values which are nearer to 1. Say if you are getting, say 0.9 or 0.8, sometimes you may select it depending upon the number of factors you have already received, right? So this is how you use eigenvalues. Then based on using a scree plot. A scree plot is a plot of eigenvalues against the number of factors in order of extraction. Experimental evidence indicates that the point at which scree begins denotes the true number of factors. Generally, the number of factors determined by a scree plot will be one or few more than the determined by eigenvalue criteria. Then there is another type of factor analysis which is called as determination based on percentage of variance. In this approach, number of factors extracted is determined so that the cumulative percent of variance extracted by the factors reaches the satisfactory level. It is recommended that the factors extracted should account for at least 60% of the variance. If you get at least 60% of variance, you select those factors. This is a scree plot. Here you can see that you can select only 2 factors because all the other factors here are below 1. So in your analysis you are getting only 2 factors. So this is how you arrive at the number of factors from the data. Now, how do you determine the number of factors? One test you can do is split half reliability method. Here what you do is the sample is split in half and factor analysis is performed on each half. The only factors with high correspondence of factor loadings across the 2 subsamples are retained, otherwise we won't consider it, right? So that is split half reliability method. Another one is based on the significance test. It is possible to determine the statistical significance of separate eigenvalues and retain only those factors that are statistically significant. A drawback here is if you have large samples, many factors are likely to be statistically significant, although from a practical point of view, many of these account for only a small proportion of the total variance. Now, how do you conduct factor analysis? Basically, there are two types of ways in which you can conduct the factor analysis. That is using the rotation. Rotation is nothing but you try to find the most possible combinations, right? So when you conduct a factor analysis, the first set that you are getting is an unrotated factor matrix, right? So you can actually, in the SPSS console, you can actually specify the kind of factor analysis that you require, whether it could be orthogonal or any other rotation method, right? So in the initial unrotated factor matrix indicates the relationship between the factors and individual variables. It seldom results in factors that can be interpreted because the factors are correlated with many variables. Therefore, throughout the rotation, the factor matrix is transformed into simpler one that is easier to interpret. So, using the rotation, you can actually find out most simpler set of factors which are easier to interpret. In rotating the factor, we would like each factor to have non-zero or significant loadings or coefficients for only some of the variables. Likewise, we would like each variable to have non-zero or significant loading with only a few factors, if possible with only one. The rotation is called as orthogonal rotation because if the axes are maintained in the right angle, then it is called as a orthogonal rotation. Another commonly used method of rotation is called as Varimax procedure. Here, the orthogonal method of rotation that maximizes the number of variables with high loadings on a factor, thereby enhancing the interpretability of the factors. Orthogonal rotation results in factors that are uncorrelated. Right? So, in the Varimax procedure, you can actually minimize the number of variables with high loadings on a factor. Thereby, it is possible for you to enhance the interpretability of the factors, right? And you also get a set with uncorrelated factors as a result. Then there is another kind of rotation which is called oblique rotation, wherein the axes are not maintained at right angles and the factors are correlated. Sometimes allowing for correlation among the factors can simplify the pattern matrix. Oblique rotation should be used when factors in the population are likely to be strongly correlated. If you feel that the factors in the population are going to be highly correlated, then you must go for an oblique rotation. Otherwise, you go for a Varimax procedure because Varimax is the most commonly used factor analysis method. Now, say after conducting the factor analysis, you get a supporting statistics. How do you interpret the result, or how do you interpret the factors? A factor can be interpreted in terms of the variables that load high on it. If you have a high factor loadings, then you can find out which are those variables and why those variables have high loadings, right? Another useful aid in interpretation is to plot the variables using the factor loadings as coordinates. Variables at the end of axis are those that have high loadings on only that factor, hence they hence describe the factor. And by once you get, say, from the 20 you are reducing it to 4, and you can actually name those 4 variables. You see which are the variables which comes under the factor 1, and according to that you can actually name the variables which is called as the surrogate variables. By examining the factor matrix, one could select for factors the variables with the highest loading on that particular factor. That variable could then be used as a surrogate variable for associated factor. However, the choice is not easy if you have 2 or more variables which have similarly high loadings. In such cases, the choice between these variables should be based on the theoretical and measurement consideration. You cannot actually blindly go and name the variables. Instead, you must also have the support of the theory if you want to name the surrogate variable. Then the final step is you determine the model fit. So the correlation between the variables can be deduced or reproduced from the estimated correlation between variables and factors. The difference between the observed correlation and reproduced correlation, that is a factor matrix, can be examined to determine the model fit. These differences are called as residuals. So in interpreting the model fit, you basically make use of residuals. Say this particular table, this is a result from SPSS. Here you can see that the components, that is the factors 1, 2, 3 and 4 has eigenvalue above 1. So you, from the 20 set, you have reduced it into 4, right? And when you further examine the factor loadings or factor matrix, you can find out which all 20 are coming under 1, 2, 3, etc. Right? And then you can name those variables. So every statistics has certain assumptions. Factor analysis also has certain assumptions. The first assumption is there should not be any outliers. Right? Another assumption is there should be adequate sample size. As I told you earlier, say if you are selecting 20, then at least 4 or 5 times of 20 should be used as a data. Then there should not be any kind of multicollinearity. Right? So factor analysis is basically an interdependency techniques. So if you feel that all your 20 variables are highly correlated between each other, then that means there is something wrong with the data set, right? So there should not be any kind of multicollinearity. And homoscedasticity. Since the factor analysis is a linear function between measured variable, it does not require homoscedasticity between the variables. Another assumption is linearity. The factor analysis is also based on the linearity assumption. Non-linear variables can be used after, however, it changes into a linear variable. Right? During the factor analysis, it will automatically convert into a linear variable. Then another assumption is always use interval data. Right? So these are some of the assumptions of factor analysis. I hope you understood the basis of factor analysis through this video. Thank you all.